Cisco SD-WAN Route Policy is a tool for route manipulation, route filtering, changing metrics or metric type, adding community, and changing AS path are some of the manipulation tasks that we can apply while receiving or advertising routes. We use policies to do many tasks in SD-WAN infrastructure. There are two types of policy: localized policy that are applied directly to WAN routers and centralized policy that are applied to vSmart controller. With localized policy, we can do many tasks: configuring route policy to manipulate or filter routes, configuring access lists to filter data traffic, and quality of service policies to guarantee bandwidth and priority for some data traffic are some of the most important policies that we can configure through localized policy. With centralized policy, we can also configure many tasks: how are branches and headquarters connected to each other, full mesh, hub and spoke, or custom topology. This is implemented through a centralized policy. Traffic filtering at application layer, traffic engineering to route traffic through a specific path, and application-based routing are some of the policies that can be configured through centralized policies. This section is dedicated to implementation of route policy. With route policy, we can filter routes, we can change metric or metric type of the routes, we can change AS path and community of BGP routes, and many other manipulation either when we receive or advertise routes. Matching of the routes can be configured based on many parameters like prefixes, AS path, and also community. Route policy can be applied to a specific neighbor or a specific interface, or even in a route redistribution between routing protocol. Route policy is not the only policy that can be applied to a device. We have many other type of policies. Many policies of the same or different types can be applied to a particular device. All the policies that must be applied to a specific or group of devices are held inside a new policy that is just a container to hold other real policies. I myself prefer to call it container policy. Container policy itself does not contain any commands. Container policy is the only policy that can be applied to a device itself through device template. Route policy is the topic of this section, and as examples, we will configure three route policies: one for OSPF and the other two for BGP. In OSPF policy, we will change metric type, and add a tag when redistributing OMP routes into OSPF, but only for a specific subnet 172.16.4 /24, which is behind CH4. Now let's start to configure our first route policy. We will configure route policy through policy and then localize policies. In the localized policy, first if section of route policy must be configured. If section of route policy. If section of route policy can be configured through custom option and then list. We have many options here, and we use here prefix. We want to match based on prefixes. So new prefix list, the name net underline 172 underline 16 underline 4, and then add. Then section of route policy must be configured, which is equivalent to writing route map in Cisco routers. Route map can be configured through custom option, and then we have many policies. Route policy is one of these policies which can be configured through localized policies. Route policy, create new OMP underline OSPF. First sequence, match and then action, match based on prefix list, and then action, accept and set metric type, and then OSPF tag, metric for example 164, metric type 1, and OSPF tag 164. Second sequence, just action accept, because the default action is reject. It means any other routes redistributing from OMP to OSPF protocol are discarded by default. So I've added two sequences and then save route policy. Since multiple policies of the same or different type can be applied to a single device, in the next step we configure a policy which I call it container policy, and it can be applied to device through device template. Container policy must hold all policies that must be applied to a device or group of devices. Container policy is just a container and there is no command behind it. Prefix, and then in route policy we can hold QoS policy, accesses policy, and also route policy. Now we are going to add route policy, import existing, and then OMP OSPF. This OSPF route policy inside container policy must be applied to Ch1 router here. So the name can be, for example, Ch1 underline policy, which will hold in the future all other policies related to Ch1 router. As I have said, policies of different type can be imported into container policy, like quality of service, access list, and also route policy. We can preview a command before applying it to a device or devices. With preview, viptela commands will be shown. As you can see, sequence 1, match address net 172.16.4, and then change metric, OSPF tag, and metric type. And then the second sequence, action accept, and the default action is reject, and this is our prefix list. These viptela commands will be translated to Cisco commands when we apply it to Cisco CSR router. Save. Now it's the time to apply container policy to Ch1 device through device template. In a device template, Ch1, and then edit. In additional template and policy, Ch1 policy. When applying container policy to Ch1 router, we can also preview command once again. Here you will see that viptela commands are translated to Cisco Roadmap commands. This is the prefix list, our matching section of the route policy, and this is our roadmap. As you see, viptela command is changed to roadmap Cisco CSR 1000V. And then configure device. Notice that with applying container policy to Ch1 router, roadmap are configured in router but not applied to any interface, neighbor, or protocol. In this scenario, roadmap must be applied to routes redistributed from OMP to OSPF protocol. Success. So now route policy or roadmap must be applied when routes are redistributed from OMP to OSPF. We will configure it through OSPF feature template. This is configured in previous sections. OSPF, edit, and then redistribute. Already OMP is redistributed into OSPF. Now we can set route policy. OMP, we don't write the name of container policy, we write the name of route policy. OMP underline OSPF. Update. The configuration of Ch1 router will be updated through these commands. When redistributing OMP route to OSPF, as you can see, the command was redistribute OMP subnet into router OSPF section, but now it is redistribute OMP subnet route map OMP underline OSPF, and then configure devices. After applying, we can check the result of our configuration with show IP OSPF database external command in data center router. In data center router. So I will connect to data center router. Show IP OSPF database external. It is successfully applied. And if we go through 172.16.4, as you can see, metric is 164, tag is 164, and metric type is metric type 1. But the other routes are metric type 2 with a different metric and a different tag. So our configuration is correctly applied. The next two policies are related to BGP policies. As you know, we have already a full mesh of BGP neighborship between WAN routers. IP addresses configured in interface loopback 5, 192.168, 11 to 14 are already advertised through BGP protocol. In this policy, BGP routes will be tagged with a specific community 100 when they are advertised. BGP routes are received only if they contain that specific community. Now we are going to configure these two new policies. Again, first, if section of the route policy must be configured. We have two if section, if 192, 168, and 00, 16. It is 16, not 26. And the other if section is communities 100, 100. So in policies, localized policy, custom option, lease, first prefix, new prefix, net underline 192, 168, 192, 168, 00 slash 16. And the other is related to community, matching community. The community name is com 100 underline 100, and the community itself is 100 100, and then add. Then section of route policy must be configured, which is equivalent to writing roadmap in Cisco routers. We need two policies, one when we receive routes through BGP and the other when we advertise BGP routes. In advertising, community 100 100 will be added to BGP routes. In receiving, only routes with community 100 100 will be accepted. So localized policy, custom option, route policy, and then add, create new, press BGP, underline out, sequence, first sequence, matching based on net address, and then action, accept, but with changing the community 100 100, and the default action will be to discard the other routes, except matching with this prefix. And the other route policy, BGP underline in, sequence, the first sequence, matching based on community list. We have already prepared community list, and then action, just accept, and no parameters are configured. And default action is also discard the other routes. Save route policy. Then these two policies must be imported into existing container policy, Ch1 policy, to be applied to Ch1 router, edit, route policy, and then import BGP out, again import BGP in. And then preview BGP out and BGP in and prefix list and community list. These are viptela commands. As you know, these viptela commands will be translated to Cisco commands when we apply to Cisco CSR router. And then save policy change. Next, this is the configuration changes. When applying container policy to Ch1 router, we can preview the commands once again. Here you can see that viptela commands are translated to Cisco roadmap commands, prefix list and community list, and then roadmap BGP in and roadmap BGP out, and then configure devices. These two new route policies must also be applied to other edge routers, so we have to create another container policy in policies, localized policy, add policy. We call it next, import to BGP in and BGP out. And the name should be, for example, Ch policy to be applied to other edge policies. Save policy, and again in template, device template, CSR 1000V device template, edit, additional template, and then Ch policy. Roadmap will be applied to all other 3 edge routers. Prefix list and community list, and then roadmap BGP in, and then roadmap BGP out. Configure device. Notice that with applying container policy to edge routers, roadmap are configured in routers, but not applied to any neighbors. So we have to apply route policy or roadmap to every 3 neighbors in BGP configuration. We will configure it through BGP feature template, which is configured in previous sections. So we go to the template, feature template, BGP, and then edit, neighbor. For all 3 neighbors, address family on, address family IPv4, route policy in, on, route policy out, on, BGP underline in. Here the name of route policy must be configured, not the name of container policy. BGP underline out. It must be configured in all 3 neighbor routers. Again, address family. And for the third router, BGP underline in and BGP underline out. Roadmap must be applied to the neighbors in BGP context mode. In router BGP, as you can see, roadmap are applied to 3 neighbors for every CH router. The final result can be checked with show-ip BGP command. We have to see all routes still in BGP, but including community. For example, in Ch2, show IP BGP, show IP BGP 192.168.11, which is related to Ch1 0. At the moment, there is no community in the output. We have to wait until the configuration is applied. Now it is applied. I think there is a mistake in our configuration. Let's check it in policy, custom policy, list, prefix. In the prefix list, I have to add here LE32 because our mask is 24. Less than or equal 32, then save. The configuration must be corrected. Again, we will check the result. Now it seems to be okay. We have to wait. Show IP BGP 192.168.11.0. As you can see, now we have a community which is equivalent to 100.168.